In this Expo SQLite episode, I'll show you how to import and export database from and to web and Android device. I think that building an offline app isn't just about allowing the user to work without the internet connection. It's also about making sure that user can back up and restore their data on another device. That's what I did with my shopping list app. It doesn't require login. You can just continue using the offline features and import and export data easily across platforms. But still, that project I'm not open sourcing, but I do want to share what I learned, and that's why I made the React Native Expo SQLite series, and you can take a look at more videos in the playlist. Prerequisites for this tutorial, except the SQLite part, specific to export and import. You need the Expo file system, document picker, and Expo sharing. Expo sharing is just a solution when you back up the data, then the pop-up opens and lets you select either Drive, email, or quick sharing. And the document picker is for selecting the document when you want to import the data. And lastly, file system, well, we need that for the recovery method. You'll see soon enough in the code where it is used. I'll first implement the solution on Android, and then I'll implement the solution on web and show you how data can be exported and imported from web and into Android. So let's get started with the Android part. This is my to-do list app, and I have a task and I have a settings page which currently only clears the data from the database, and I'll add two more buttons for export and import. First will be called import, and this is asynchronous method, and I have an ops client already method for importing data, but it doesn't do anything. And export, what it does, I also have a placeholder method which doesn't do anything. If I take a look at the implementation, sorry, this is an interface. If I take a look at the implementation, I call import and export, you should throw an error. I handle promise rejection. And now onto the implementation. Instead of throwing this error, I will delegate this to the SQLite database module. I also have the web representation one that instead of this native one gets called in web, but let's focus on the native part. And I call it, for example, backup database. And the argument is name of the backup, and it will throw an error, and also goes for restore database, which takes in SQLite database and also throws an error. Instead of this, I have to re-export. Here I will call backup database, restore database, and we'll tell it to accept the backup name. And here I'll tell it to call it test backup.sqlite, and I basically did nothing except delegated this functionality to SQLite database module, but that's okay because there will be two different implementations of backup and restore, because environment is different on web and on native. For backup, I need access to the file system directory. And I'll also need sharing, because that's what I back up, I need to share. And instead of just throwing an error, I will replace it with an implementation. And my database path is located in the app path, and SQLite, and database name. It is same for any kind of app on Android. And my backup path will be the same, except it will be called by the backup name. And what I do is copy the database to the backup path. And lastly, I'll share what is copied. Under MIME types, since this is SQLite, I save it as SQLite 3 and cleaning up a bit. And idempotent true will clear the file if it exists. If it doesn't throw an error. And I'll wrap this all in the try catch. And what else is missing over here? Well, if you have a write ahead log enabled, your database, when you use it, creates 2 more files, and those indicate changes that are not yet committed. And this is an SQLite way of enabling concurrency when reading and writing. I think usually when the system does writes, reads are logged. To have the changes from the journal also in your backup, you call the pragma for write ahead log checkpoint. And this should make it possible to not lose any of the changes that are currently in the journal file. But if you're not using the write ahead log, if you don't have the extra files, maybe you don't need this extra step. And now let's see the backup. If I call the backup, and now when I call the export part, it should open the sharing file, so it managed to backup my database. This is tedious to test on the Android emulator, so I'll just skip and you'll have to believe me that it really is exported, or you can just take a look at the source code and test it yourself. So I did the export, and now I'll do the import part, or the restore database. For restore database, you'll have a document picker where the user will select which document will be used for restoring. And MIME type is a wildcard. I tried setting the MIME type application SQLite 3. I also tried the Octet stream, but it just didn't work. So quick workaround was allow everything. And document picker comes from Expo document picker. Few extra options. And only single file will be selected. And user can sometimes cancel document picking, and I don't want to continue with the process. And the backup path of the document that the user selected is first asset and URI path. And we will also check after selecting if it was in the mean type deleted. So I will check if the document exists. Also skip the process if it doesn't exist. And now for the next part, when working with Expo SQLite, I need to close the database and reopen it later, because the changes that I would import without touching the database connection, it would still hold the old data. It wouldn't work as expected. So I'm closing the connection, and after importing, I will reopen it. And database path is this one. And also there may be a situation where write ahead log journal has been created, so I need to I need to delete those files. And it shouldn't happen, but it shouldn't happen that they exist because I will also create a checkpoint, and also when closing the database, those files should disappear, but just in any case, I will delete them. And similarly, like I did in the backup database, I will also do a file system copy asynchronous, but the other way around, from the backup path to the DB path. And also I will wrap this in a try catch. And here it is, I have the restore database, but what now happens? The application will no longer work until I reopen the DB connection, so I need to solve that issue. But let's first... And now I need to solve the problem of reopening connection for the database. And for that I'll go back to settings. And here, after the restore, I need to do a database reload. And to restore the connection, let's go back to the SQLite provider. And this is my provider that initiates the database. And this is my function that initiates the database. I'll extract it outside and provide it from a context to be used. And then I will extract the typing of the value, and it will not be just SQLite database. It will also contain a function that calls the setup method, but better name would be reload. And reload is an async method where I need to fix these flags and make it possible to call the setup. Otherwise, setup will be called, but it will not do anything. Here I have added a method, and now I can use it in the settings page. Let's call it dbctx. SQLite context. And where was I? After restoring, I can call reload. And to test this import and export, I will export it with the device explorer, because it's tedious to do so with the emulator. To access the app local data, you will go to data and name of your package. And for SQLite, it will be located in the files SQLite. And this is my database. I will save it in my project directory. And this is it. And if I take a look at what's actually in there, it will contain my data. And let's go back to the running device. And now I will test the import data if it functions correctly. This is now empty. To import the file, I can also use again the device explorer. And instead of importing it over here, I will import it to storage emulated download. And now when I click on the import, go to downloads, it should appear. So the data is imported and the database connection is restarted, and that works on Android. So next implementation will be on the web. And now for the web implementation part, here is my web-specific module for Expo SQLite port to the web, and it uses sql.js. And to make it work, I had to make an adapter, which is an open database async, which instead of the native implementation calls sql.js. And this will scream on the web because I don't have the backup database and restore database functions implemented. So let's implement them. And it will be completely different from the native. And for backup database, there's a neat function in the sql.js called db export. And the import. These two methods will only be called in the web representation. And what does it do? The export part calls the sql.js export and it exports to binary array, and same thing with import, it receives the binary array of your database. I use the indexeddb as a store for handling sql.js SQLite state in the web. Without this, state wouldn't be persisted. And let's take a look at the backup database, restore database. I will implement the backup database first. And to not bother you with typing, this is the usual function when I need to save something from the browser. This is what I call. It isn't just a function for backing up a database, so maybe it would be useful to extract it to utility. And for the restore database, this is functionality that enables opening a document selector and opening a file reader, which I have to wrap in a promise because I need to return the result based on the result from onload or on error. My onload is the part that reads the document selected file and turns it into a binary array. And lastly, that binary array is passed to the db import, and db import is only implemented on the web specific part. It calls the save to indexeddb. This saves the state to the database, and since the rest of the functionality is already implemented, and by that I mean the SQLite provider reload, it will act the same as the native implementation, and since reload is called, it reinstates the sql.js database from the state that is found in the indexeddb. So let's test it. And this is how the app looks on the web. And export will export the current data. Apologize, the backup database won't work because I can't pass just the binary array. I have to create a blob object. And from that URL can create it can create an object URL. Okay, and instead of file content, I will pass the create object URL. And this is my web to-do demo app, which contains exactly 3 records. And when I click on export, let's call it web export. And I want to import that what I exported from the native SQLite. Remember that the list 1 and list 2, it was exported from the native emulator, and now it works on the web. And I can also re-import the web exported file. So this solution is cross-platform, works on Android, works on web. And it also works on iOS. I haven't tested this demo part, but same functionality is also on my iOS version of List Duo, the shopping list app. So confirmed it works. Okay, so this video now covers the importing and exporting from Android, tested on emulator and tested in the web browser. All of the code, as usual, you can take a look at GitHub and you can test for yourself. And if you see a bug or an issue, tell me so in the comments or open a GitHub issue. And thank you for watching this video.